Hey, good morning, everybody. This is Mr. Ainsworth here at home during this crazy pandemic, global pandemic here in 2020. And I am going to go through a couple of the homework problems here for you in case you need some help at home. Okay, so let's get right into it here. Only watch this video if you've attempted it, okay, and get out your pencil, red pen, and all that kind of good stuff. And we can get right into it and check out how it's done. Uh, To do this right here, some of them require a calculator, some of them do not. Okay, and when we do, if you do not have a T84, well then guess what? We have a very useful tool handy called Desmos. Let me pull up Desmos here. And so just type in desmos.com and use the scientific calculator here. It can do all your trig for you. All right, so have that handy and we can get right into it. So let's go for it. Let's solve secant squared of theta equals 9, where theta is between 0 and 360 degrees, and including 0. So we're going to find all solutions between 0 and 363 degrees, if there are any. Okay, so let's go for it. All right, so let's take secant squared theta. Whoa, sorry, secant squared theta equals 9 right here. And because it's secant squared theta, we're going to square root both sides, okay? So square root the left and square root the right and put that plus or minus symbol in there because there are two roots of 9 there, okay? So we got the square root of secant squared theta is just secant squared. Excuse me, secant of theta, sorry. Come on. This is in the morning. I got to get my groove on, okay? And that's going to be equal to plus or minus 3, right? Because 3 squared is equal to 9. Okay, now what we're going to do is reciprocate both sides because this right here is 1 over cosine theta. I'm sorry, I don't know why it's doing that. So 1 divided by cosine theta is equal to plus or minus 3. And what we want to do is reciprocate both sides. Okay, and the reciprocal of 1 over cosine theta is cosine theta. All right, so there's the reciprocal right there. Reciprocal of 3 is 1/3. So cosine theta is equal to plus or minus 1/3. All right, and because of that, we have 4 solutions. All right, because we actually have 2 equations here. So cosine theta could be a third. All right, we'll get some solutions right there. And then cosine theta could be equal to negative 1/3. All right, now 1/3 does not exist on the two nice triangles, the 30, 60, 90 and the 45, 45, 90. So let's draw these up here, okay? The 30, 60, 90 is long and narrow because it's scalene. All right, 2, 1, rad 3. And notice that the ratio of 1/3 is not on there. 1/2 is, root 3 over 2 is, 1 over root 3, root 3 over 1. All those ratios are on there, but not 1/3. So this is a calculator problem. And then the 45, 45, 90, as you guys know, look like this. It's isosceles. Both legs are root 2, and the hypotenuse is 2. And so the ratio of 1/3 is not on that triangle either, which indicates that this is a calculator problem, so calculator required here. Okay, so what we're going to do is we understand that cosine's positive in quadrants 1 and 4. All right, so we need a quadrant 1 solution, we need a quadrant 4 solution. So theta here is going to be equal to the inverse cosine of 1/3. So let's go to Desmos here and let's work on that. Ooh, where is it? There we go. All right, now on the front part of the calculator here on the main page here, we just have sine, cosine, and tangent. So let's go to functions here and let's pick inverse cosine. All right, let's type in 1/3. All right, so 1 divided by 3. We'll get an answer here. All right, we get about 70.529 degrees. We'll be accurate as possible to the nearest thousandths. Okay, so here we go. So we have one solution here, 70.159 degrees. All right, make sure you put the degree symbol on there. And theta 2, that's theta 1. Theta 2 is equal to some angle that's in quadrant 4 because cosine is positive in quadrants 1 and 4. It's negative in quadrants 2 and 3. So to get that, I need to take 360 minus this. So 360, oops, 360, all right, minus 70.159 degrees. What is that? Well, let's go back to Desmos again, right? Because we're using technology here. So here we go. So 360 minus 70.159 roughly. Oops, excuse me, 529. So let me go back. 0.529. Got to type it in correctly here. And this is an approximation right here because I approximated the first angle, so the second angle is also approximation. So 289.471. So we have 289.471 degrees. And there's my second angle, or second solution, between 0 and 360 degrees. Remember, we're trying to find all solutions in that interval. Now, it's negative in quadrants 2 and 3. So I have a quadrant 2 angle and a quadrant 3 angle. So here, theta is equal to the inverse cosine of negative 1/3. So let's figure that out. So let's go back to Desmos again. And let's take the inverse cosine of negative 1/3. So type in negative 1 divided by 3. And notice that we get this angle here. All right, 109.471 degrees. And obviously that's a quadrant 2 angle. All right, so that's our first angle right there. So our first solution, or the third solution actually, because I got two already. So I've got this one, and now I've got another one. So what is that? So let's write down 109.471 degrees. Okay, there we go. How do you get to quadrant 3? Well, to get to quadrant 3, you need to get the reference angle in quadrant 1. And that's 180 minus this, which happens to be right here, 70.159 degrees. And so what we want to do is take the reference angle and add 180 degrees to it. So this is theta 3, so theta 4 right here, theta 4, come on. Just take our reference angle, this is our reference angle right here, in quadrant 1, and I'm going to add 180 degrees to it to get to quadrant 3. So I take 180 degrees plus this one, 70.159, because that's our reference angle, and I get 250.159 degrees. So 250.159 degrees. And that's my quadrant 3 angle. So I have 4 solutions here in that interval from 0 to 360 degrees. All right. Okay, quadrant. All right, so here we go. That's number 1. Number 2. Okay, number 2. How do we solve this one? This is going to be fun. Okay, now this equation here is called a quadratic. Okay, and it's very, very similar to this equation right up here. So 6x squared minus 7x plus 2 is equal to 0. It's called a quadratic equation. And what we want to do is try to factor it. Okay, factor the quadratic, just like you did back in Algebra 2, well, Algebra 1, Algebra 2, and in first semester. So factor the quadratic into two binomials, but instead of x, I've got sine theta. No big deal. All right, so we're going to try to do that. We're going to try to factor it into two binomials. And again, we're trying to find all solutions on that same interval between 0 and 360 degrees. All right, and there are many ways to factor this quadratic here. I'm just going to do basic FOIL method here. I know that the first times first equals the first, and the factors of 6 are 3 and 2, and 6 and 1, and 3 and 2. So I can put 3 sine theta here, and then 2 sine theta here, because I know that 3 sine theta times 2 sine theta is 6 sine theta squared theta, right? Because 3 times 2 is 6, and sine theta times sine theta is sine squared theta. All right, the factors of 2 are, we only have two choices, 1 and 2. So I got to put those in. So it's either 1 and then 2 or 2 then 1. You got to play with the values. If I put 1 and 2 here, then you got to check to see if this works. So right here and here, the inner and outer products have to add up to this middle term. The inner product here is 1 or 2 sine theta, because 1 times 2 sine theta is 2 sine theta. 2 sine theta, and the outer product is the 3 sine theta times 2, which is 6 sine theta. And if you add these two, there's no way to get a negative 7 sine theta. So my choice of 1 and 2 is not correct. Okay, so we're going to erase this and this. We're going to erase the 1 and 2, or switch the 1 and the 2, and we're going to go 2 and then 1. All right, so what do we get? 2 times 2 sine theta is 4 sine theta. All right, and 3 sine theta times 1 is 3 sine theta, and this works. 3 plus 4 is 7, but I want them both. I want a negative middle term here, so I need to make them both negative. All right, and not only that, negative 2 times negative 1 is positive 2. So checking with FOIL or checking with the distributor property works. And at this point, you want to use what's called the zero product rule. All right, the zero product rule, which comes all the way back to algebra 1. And because we have a binomial time, something times something equals 0, this product has to be equal to 0. And the only way for that to happen is if you take 3 sine theta minus 2 and set equal to 0. And then the other binomial here, this 2 sine theta minus 1, well, that could be equal to 0 too. All right, because we know that anything times 0 is 0. That's what the zero product rule is all about. One of these binomials has to be equal to 0. So then you solve them. Okay, you use some basic algebra 1 here. Okay, and then divide by 3. And you get sine theta is equal to 2/3. And 2/3 is not on these triangles up top either. Okay, they don't exist on these triangles. So this is another calculator problem. Okay, so what we need to do is take the inverse sine of 2/3. And now sine's positive in 1 and 2. So quadrants 1 and 2 are solutions. So theta is equal to the inverse sine of 2/3 here. So let's do that on Desmos. Let's take the inverse sine this time of 2/3, 2 divided by 3. And notice that we get 41.810 degrees. All right, and that's our first solution. So we've got 41.810 degrees. To get to quadrant 2, you take 180 minus that. Okay, so theta 2, the second solution is in 180 minus this one. Okay, and then, so you type in 180, right, minus the previous answer, 41.810. And you get 138.19 degrees. So, oops, didn't mean to do that. So you get 138.190 degrees, and there's your second solution. So we already have 2 solutions. Now we got to find the other 2. So let's do that. So let's add 1. We have 2 sine theta is equal to 1 divided by 2. Okay, and so sine theta is equal to 1/2. And this gives us 2 solutions. All we have to do is figure out the sine, what angles give you a ratio of the sine of what angles give you a ratio of 1/2. And again, these are quadrant 1 and 2 angles, but they're different than the previous 2, and we don't need a calculator here because we know the triangles. So the sine, let's go back up here. The sine of 30 degrees gives you 1/2. Okay, there we go. So we have our next angle here, which is 30 degrees. And then the quadrant 2 is 180 minus that, which is obviously equal to 150 degrees. Just look at you in a circle there too. You can see what I'm talking about. The sine of these angles give you a ratio of 1/2. Okay, so this is part of it's calculator based and part of it's not. All right, number 3. And by the way, if I'm going too fast, this is a video, right? So obviously, pause, play, rewind, listen to it as many times as it takes to follow it and, understand what's going on, because each one is a little bit different. Like this one involves different algebraic techniques. So here, what I want to do is I notice that I have 2 cosine squared theta, or x here in this case, because I'm dealing with x. Oh, I got to switch this. This should be x right here. I want to solve for x here from 0 to 2 pi. So this is in radians. So radian modes here in radians, and fix that right there. I should have put x is between 0 and 2 pi because I switched my variable to x here, and this should be x here too. So my intervals are from 0 to 2 pi in this case, and they're in radians. Both are in radians. So this next one here, the fourth one, is also going to be in radians, just to switch things up, because you got to get used to that. In calculus, they do a lot of work in radians. Now, in this case here, you've got 2 cosine squared x equals cosine x, and you have a function on both sides of the equation. So what I want to do is get the functions in on one side, and I notice they have something in common here because I don't have a trinomial. So I'm going to subtract cosine x on both sides. So subtract cosine x on both sides. What do we get? We get 2 cosine squared x minus cosine x is equal to 0 because cosine x minus cosine x is 0. Right there. Now, this is not a trinomial like the previous one, so we're not going to factor into two binomials. What we're going to do is we're going to factor out the GCF. This is a very common technique whenever you have two terms instead of three terms, and they have something in common, we'll call it the GCF. You always want to factor out the GCF. So make sure you put that down in red. That's a very common technique. So I'm going to factor out cosine x here, and I get cosine x is equal to 2 cosine x minus 1 equals 0. You can check that by distributing back through. Okay, look at that. Cosine times 2 cosine x gives you 2 cosine squared x, and then cosine x times 1 or a negative 1 gives you a negative cosine x. So it checks out. And then you got a zero product. Okay, so what we're going to do is we're going to use the zero product rule here, just like we did on the previous one. So I know that cosine x could be equal to 0. And the next one, I get 2 cosine x is minus 1 could be equal to 0. Again, I'm using the zero product rule here. And then cosine 0 at the top of the unit circle and the bottom of the unit circle. Okay, and that means that x is equal to pi halves here. Okay, and 3 pi halves. Okay, just look at your unit circle right there and you'll see what I'm talking about. The x coordinate at the top of the unit circle at 90 degrees and then at the bottom of the unit circle at 270 degrees is 0. All right, and so cosine is equal to 0 at those 2 points. Now over here we got something different. We add 1. All right, do some basic algebra. All right, this should be easy for you pre-calc students. And then divide by 2, and you get cosine x is equal to 1/2. And once again, this is on the special right triangles right here. The cosine of 60 degrees is 1/2. So you don't need a calculator here, no calculator required. All right, so x is equal to 60 degrees, excuse me. That should be, we're in radians, so that's pi thirds. That's your quadrant 1 angle, quadrant 4 angle, okay? And the way you get that is if you take 2 pi minus that. Let me write this a little bit better here so you understand it. So my quadrant 1 angle, x is equal to 60 degrees or pi thirds. My quadrant 4 angle, I'm going to do the same way I did the previous problem. I'm going to take not 360 but 2 pi minus pi thirds. All right, and you get 5 pi thirds. So I have 4 solutions here. I've got pi halves, 3 pi halves, pi thirds, and 5 pi thirds. There we go. All right, last one. Here we go. Same sort of idea. This one's similar to the previous one in that they have a common term. All right, so what I need to do is get all the functions on one side and factor out the GCF. So I'm going to take tangent squared x is, no, I got to subtract. I'm going to subtract 2 tangent x sine x on both sides. So minus 2 tangent x sine x. So notice that I just subtracted the right side. Okay, I got the right side equal to 0 by subtraction. And notice that they have a common term. And whenever they have a common term, always factor out the GCF. Let me write it out again. Factor out GCF, which is basically your common term. That's a very common technique. And so let's do that here. All right, so we got tangent x times tangent x minus 2 sine x equals 0. All right, distribute back through and you'll see that it checks out. Now kick in your zero product rule. Notice that I'm doing the same thing on each problem. I'm using the zero product rule again. So we have tangent x minus 2 sine x equals 0. So when is tangent x equal to 0? So one way to think about it is to understand that the tangent x is defined to be sine x divided by cosine x. And then you got to use your common sense here a little bit. You got to think, when is a fraction equal to 0? And the only way for a fraction could be equal to 0 is when the numerator is equal to 0. So you need to focus on is when is sine x equal to 0? Let me write that down. When is this equal to 0? And it's equal to 0 at 0 degrees and 180. But we're in radians. So x is equal to 0 radians or pi radians. So I already have 2 solutions here. Now on this next one here, I get 2 different functions. So I'm going to rewrite tangent in terms of sine and cosine. So I know that tangent x is equal to sine x divided by cosine x. So I'm going to rewrite it in terms of sine and cosine so I can see something in common. What I'm going to do here is something that we do in algebra a lot. To clear the fractions, what I'm going to do is I'm going to multiply both sides by cosine x. And I got to distribute through. All right, so here we go. So distributing through, I get cosine x times sine x divided by cosine x. So these are going to cancel. And so I just get sine x. And then cosine x times 2 sine x is 2 cosine x times sine x. And then anything times 0 is 0, so the right side is still 0. And now notice, all right, they have something in common. All right, and as I said 3 times in a row, factor it out. So factor out the sine x, and then kick in your zero product rule, which we've used 3 problems in a row. So using the zero product rule, we know that either sine x has to be 0 or 1 minus 2 cosine x has to be equal to 0. And as I said before, when sine x is equal to 0 is when x is equal to the 0 or pi radians. And then here, if I add 2 cosine x to both sides, I get 1 is equal to 2 cosine x. Divide by 2, and I get a half equals cosine x. And we've already solved this before. Okay, the cosine of, look up here, 60 degrees or pi thirds, that angle is pi thirds, is equal to 1/2. So x is equal to pi thirds, and the quadrant 4 angle, 5 pi thirds. And there we go. That is the solutions for all 4. And since it's a video, my friends, you obviously can watch any one of them again to get further understanding. All right, so use it to your advantage. I'm here just to help you here, virtually this case. And I will see you in my next hangout with you guys. All right, the next Google Hangout in our Google Classroom. I look forward to seeing you. You guys have a good weekend, and I'll see you soon. Bye-bye.